So, welcome everyone. This is lecture number 6, and in today's class, we will be dealing with capacitors and resistors and RC circuits as we know it. But before going into that, what we shall do is I'll have a quick recap of what you might already know. I'll just go through this so that we are in tune with what we are supposed to do in today's class. The first thing, because we are dealing with capacitors, I hope you know what is a capacitor. Yes or no?
Yes, sir.
It is an arrangement of two plates. One of the plates is known as the positive plate. The other one is known as the negative plate. And the charge on the positive plate is directly proportional to the potential difference. And Q is equal to CV. C is known as the capacitance of the capacitor. We know this, yes or no?
Yes, sir.
Okay. The energy stored in the capacitor is half CV square. We should be knowing this, yes or no? Now, the type of question that we are going to deal with is what is going to happen when you charge a capacitor. When you connect it to a battery, what happens is the capacitor starts to get charged, and the charge on the capacitor tries to build up. Now, this is an RC circuit, as you can see. As you can see, this capacitor C is getting charged through a resistor R with a battery of EMF E. Now, basically, this capacitor will get charged very quickly. 99.9% of the charge on the capacitor will come in maybe microseconds or milliseconds, depending on the time constant. Theoretically, it will take infinite time to get it fully charged. Do you know this? Yes or no?
Yes, sir.
Now, you must be knowing that, during that time when the capacitor is getting charged, the charge on the capacitor is going to change continuously, and that stage is known as the transient state. Do we know? Have you heard this term, transient state?
Yes, sir.
Okay. Now, during this transient state, the charge on the capacitor is going to change, and that is what we are dealing with in this class. Now, if I think of capacitor as a resistor, now capacitor is definitely not a resistor, but capacitor does offer resistance to the flow of current. I mean, if you talk about AC circuits, AC current or AC voltage, we call it as capacitive reactance. Yes or no?
Yes, sir.
Similarly, we can think of this capacitor for the sake of argument that when the capacitor is getting charged at time t is equal to 0, and we will see it through the equation, at time t is equal to 0, the capacitor behaves as a short circuit. Whatever branch the capacitor is in, that branch will behave as that there is no capacitor in there at all. Do we know this? Yes or no?
Yeah, yes, sir.
And once the capacitor is charged, so what I say, at time t is equal to 0, the capacitor behaves as short circuit, and at time t is equal to infinity, that means when the capacitor has got charged, it will behave as an open circuit. Do we know this?
Yes, sir.
Now, whenever a question comes and you find resistor and capacitor or only capacitor in that circuit, and they ask you what is the charge on the capacitor, which charge are they asking about? When someone asks you what is the charge on the capacitor in general language, which charge are they asking about? They're asking about the charge at infinity. Do we understand this?
Yeah, yes, sir.
That is the maximum charge on the capacitor. If the capacitor is getting charged, that is the charge that everyone is going to ask. So I will call that charge as Q infinity.
Q.
Do you understand this?
Yes, sir.
Books may call it Q naught, but I will call it as Q infinity because
Q
I'm going to
infinity.
call this charge as Q naught,
Q
which is
naught.
the charge
Q
at
zero.
time t is equal to 0. Do we get this? Yes or no?
Yes, sir.
Now, in general, how are we going to find Q naught? Q naught would normally be given to you at time t is equal to what was the charge on the capacitor. In most of the cases, at time t is equal to 0, the charge is going to be 0. Yes or no? That means the capacitor would be uncharged. That is how a general question will look like. But There can be questions where the initial charge on the capacitor at time t is equal to 0 is not 0. We'll also look into those questions. So Q naught would normally be known, and they will ask you what is the value of Q infinity, the charge on the capacitor after a long time. Now, how do you find the charge on the capacitor after a long time? Your answer. That is the normal charge on the capacitor that you have found out in almost all the questions that you have done. How do you find the charge on the capacitor to infinity? That is my first question.
At T infinity, you will get Q equal to EC.
Can you speak a bit louder, beta?
At T infinity, we'll get Q equal to EC.
At t is equal to infinity, we get Q is equal to CV. Okay, C stands for the capacitance of the capacitor. What does V stand for?
EC.
EC. Okay, what does E
Cell.
stand for?
Cell.
E stands for the cell. Okay. Chalo. And then this is the time that I should bring a question in, right? So that I understand how much you have understood about this, because I'm having a certain amount of doubt. So rather than me remaining in doubt, it's better that I give you a question and then you solve it and my doubts are arrested. Okay? Can you do that?
Yes, sir.
So here comes a question, and I'm going to devise a question for you. I'm going to draw a circuit. And this is the circuit that I have drawn. The battery is E. All the resistance, let us say, are R each. And this is the capacitor C. This capacitor C is, let us say, initially uncharged. And my question is, what will be the charge on the capacitor? I mean, there must be a switch somewhere. I did not make it. If I make it now, the entire circuit will go away. So there is a switch. The switch is switched on, and the circuit is completed. What will be the charge on the capacitor? This is how the question would be asked. But the meaning of that question is, what is the charge on the capacitor at infinity? At 0, the charge is 0. I hope you understand this. It is uncharged. Yes or no?
Yes, sir.
Then I want you to tell me what will be Q infinity equal to. And I'll give you 2 minutes to do this. Have you done this question before? Doesn't matter. We'll do it now. 2 minutes. So I've added another question in this. And the question is, I've put a switch. At time t is equal to 0, the switch is switched on. And you have 3 currents, I, I1 and I2. And you have to tell me the value of I, I1 and I2 as soon as the switch is switched on. Do you need help? Shall I help you first? And then probably you can do it for the next question. Anyways, I'll give you 2 minutes to think about this. So how I'm going to ask this or solve this question? Remember, as soon as the switch is switched on at time t is equal to 0, at time t is equal to 0, this capacitor, the yellow thing, it behaves as
Like
a short circuit. It behaves as a short circuit. That means it behaves that it is not there. Now it behaves as it is not there. The circuit would look like this. How would the circuit look like? I will just take this off, and it will just look like this. And it is very easy to find out the current in all the 3 branches. This resistor and this resistor come in parallel, yes or no?
Yes, sir.
So it becomes R by 2. And R by 2 and R are in series. You can easily find out the value of I, I1 and I2. Yes or no?
Sir, if you connect a switch, then it will be short circuit, no, sir?
Beta, as soon as you put the switch on at time t is equal to 0, capacitor behaves as short circuit. Do we understand this?
Yes, sir.
So capacitor behaves as it is not there in the circuit.
Yeah, yes, sir.
Okay, got this?
Yes, sir.
So you can easily now it's a simple circuit consisting of three resistors, two of which are in parallel and then they are in series. You can easily calculate the value of I1 and I2. Yes or no?
Yes, sir.
What is the value of I1 and I2? Tell me fast.
Sir, I का 3 V by 3R I got.
I का 2E
V,
by 3R or 2R by
V,
effective resistance will be R by 2 plus R. That will be 3R by 2, right? So this will be 2E by 3R. Yes or no? I. This would be E by R. E by 3R and it will be E by 3R. Am I correct?
3R. Yes, sir.
So this is how the circuit behaves at time t is equal to 0. Do we understand this?
Yes, sir.
No doubts on this?
Yes, sir. Got it, sir.
Okay. Now what I'm going to do is I'm going to put another condition at time t is equal to infinity after a long time. Find the value of I1 and I2. At infinite time, find the value of I1 and I2, and I'll give you 2 minutes to deal with this one. Okay, the answer is very simple and E by 2R. What is the current I1, I2? Again, remember, at time t is equal to infinity, the green one, how does the capacitor behave like? It behave like an open circuit. Yes or no?
Yeah, yes, sir.
So it behaves like it is not there. The circuit has become open. Yes or no?
Yes, sir.
If the circuit has become open, the value of I1 becomes 0 because there cannot be any current that flowing in the open circuit. Yes or no?
Yes, sir.
That is gone. Now there's only one circuit, the inner circuit. The total resistance is 2R and the current in I and I2 will be same and that will be
E
equal
by
to E by
2R.
2R, E by
By
2R. Yes or
2R.
no?
Yes, sir.
Okay. That is how you find the value of currents at time t is equal to 0 and at time t is equal to infinity for a capacitor. At time t is equal to 0, capacitor behaves as short circuit. At time t is equal to infinity, capacitor behaves as an open circuit. Am I clear?
Yes, sir.
But now that was not the main question. These are just supplementary question that I made. If this question comes in a JEE, it will be more in a form of a comprehension where they ask you more than one question or multiple choice. So it would be a scoring one. My intention was not to find out I1 and I2. My intention was something else. I asked you what is the charge on the capacitor at infinity. Yes or no?
Yeah, sir.
That still remains a question. So now again I give you time to find out the final charge on the capacitor, charge at infinity, or the simply charge on the capacitor, and I'll give you 2 minutes to think about it. Don't worry, it's a very simple question. Maybe you did not understand the theory behind it. Okay. Now, whenever anyone is asking the charge on the capacitor, he's basically asking the charge at infinity. We understand this?
Yes, sir.
At infinity, in whatever branch the capacitor is there, that branch will always behave as what? I just not told you. At time infinity, whatever branch the capacitor is, that branch will
Open
behave as
circuit.
what? It will behave as
Open circuit.
open circuit. Good. If you remember these two things, what you got to do is actually the capacitor was connected here. Yes or no?
Yeah.
Now to find the charge on the capacitor, what you got to do, bacha, is simply find out the potential difference between
A and
points
B.
A and B, which is the plates of the capacitor. Yes or no?
Yes, sir.
Now at infinity, the potential difference between these points A and B, since there is no current in this branch, do we understand this?
Yes, sir.
The potential difference between these 2 points will be same as potential difference between these 2 points. Yes or no?
Yes, sir. The answer CV by 2.
Yes, the answer is CV by 2.
Yes, sir.
So just have to find this potential difference. How do you find this potential difference? You just find the value of I2 multiplied by R, that is the potential difference, multiplied by C, and you get the value of Q infinity. What is the value of Q infinity? CE by 2. Do we understand this?
Yes, sir.
This is how you have to do any question that comes where resistors and capacitors are given and you are asked to find the charge on the capacitor. Remember, it is charged at infinity. Remember, at infinity, capacitor behaves as open circuit. Find the potential difference across the branch of the capacitor, across the plates of the capacitor, and you are done. Shall we move ahead?
Yes, sir. Okay, sir.
Okay, then we move on to a question that was there in your sheet, the last sheet, and which I skipped because I wanted to do it today. And here comes the question. And the question is pretty simple. The question says that find the potential difference across the capacitor in volts. Basically, once you find the potential difference across the capacitor, you should be able to find the charge on the capacitor. Yes or no?
Yes, sir.
So whether it's the question of potential difference across the capacitor or it is a question of charge on the capacitor, both the questions are same. This is an integer type question. Example number 32 from the sheet, and I give you 2 minutes to solve this. Shall I do it? How this has to be done? It's a perfectly similar question to what we had done. Again, remember, at time t is equal to infinity, what happens, bacha? Capacitor behaves as open circuit. So there cannot be any current in this branch. Yes or no?
Yes, sir.
So now what happens? This current coming from here, it will go here. One path is here. Then again, these two currents will meet here and then they will come. Yes or no? This is how the current will flow. Yes or no?
Yes, sir.
This resistance and this resistance, they come in parallel. Yes or no? Oh, sorry.
Yes.
First, this resistance and this resistance,
The
they come in
order
series.
series.
Yes or no?
Yes, sir.
Then it comes in parallel. Yes or
Both are in
no? That
parallel. Yes,
becomes
sir.
2R by 3.
Yes, sir.
Yes or no?
Yes,
I
sir.
mean, it becomes 3R by 2. Okay? R
Yes,
and
sir.
R
Got
in,
it, sir.
sorry, R and R in series 2R. 2R in parallel with R is 2R by 3. Then this 2R by 3 and R are in series. Yes or no?
Yes, sir.
So from there you get the value of I. I will become as 3E by 5R. A very simple question on circuits. Yes or no?
Yeah.
Then what you got to do, bacha, is you have to find the potential drop across the plates of the capacitor. If I call this point as A and this point as B, there is no current in the circuit in this branch. So you have to find potential difference between these 2 points A, B. Yes or no?
Yes, sir.
You can do that. Yes or no?
Yeah. Yes, sir.
And I think the answer is coming as 4E by 5. Yes or no?
Okay, sir. Okay, sir.
Do you realize what mistake you had done?
Yes, sir.
What mistake?
पोटेंशियल डिफरेंस का वो मैं आर कंसीडर किया सर आपने आर कंसीडर नहीं किया मैंने कंसीडर किया सर
Okay, so you realize your mistake?
यस सर
Try not to commit such mistakes, okay?
ओके सर
Okay, what I'll do is, I think you will need one more problem on this. Yes or no?
यस सर
Yes, just give me. Here is this. Okay, I will get you a problem on this. think here. Yes. Okay. So you do this one to find the charge on the capacitor. Each resistance is R. Can you find out the charge on the capacitor? When I say charge on the capacitor, I mean charge at infinity. We understand this? I'll give you 2 minutes. You got the answer? What's the answer is?
CE by 2.
CE by 2. How did you get CE by 2? You
Sir, this
understand
circuit will short, sir.
this circuit will
Both the resistance will not pass current.
this circuit will be open circuit, so you have to find the potential difference between these 2 points,
Yes,
which
sir.
is same as the potential difference between these 2 points. Yes or no?
Yes.
What is the current in the circuit? There is no current in this branch.
Yes, sir.
What is the current in the circuit? E by 3R.
E
Yes
by
or
3R.
no? What is the potential difference between these 2 points? E by 3R into R multiplied by C.
C.
E by
E
3
by.
and not 2 beta.
Yes, sir. 3.
So we got this?
Yes, sir. Got.
Okay, so this is how you will find out. And this is obviously charge on the capacitor at infinity. Do we
Infinity.
understand this?
Yes, sir.
Charge on the capacitor at infinity. This is how you can always find it out. So are you confident of this now?
Yes, sir.
Okay, at last. Then we know how to find out the charge on the capacitor at infinite time, and now we can move on to the actual concept
Sir,
of
if potential difference on capacitance, what will do, sir?
potential difference across the capacitor is E by 3.
E by 2. E by
E by
3.
3 beta, E by 3.
E by 3.
Yes or no?
Yes, sir.
E by 3, and you multiply this E by 3 by C and you get the charge on the capacitor. Yes or no?
Yes, sir.
Okay. Now we move on to the question where what we have is the transient state. Do you understand what I mean by transient state? What we have found out just now is the final charge on the capacitor, but in between 0 and infinity, the capacitor gets charged, and that process is known as transient process. Your book might call it charging and discharging of the capacitor. Do we remember this?
Yes, sir.
Simple circuit. And remember the simple points of the circuit. You have a resistor R, you have a capacitor C, you have a voltage drop across the resistor, you have a voltage drop across the capacitor. This must be equal to, if I add, that will be equal to V. Yes or no?
V, yes, sir. VC plus
In
V.
discharging, what happens? You have taken off the battery off, the capacitor will discharge. The same sort of thing happens. VC plus VR is equal to 0 in this case. You all understand this? Yes or no?
Yes, sir.
Now, if you understand this, then you can find out the final charge on the capacitor, or charge on the capacitor is a function of time. Yes or no? This is for the charging circuit on the left hand side, and this is for the discharging circuit on the right hand side. Do we understand this?
Yes, sir.
Q is equal to CV into 1 minus e to the power minus t by RC, where RC is known as a time constant. This is written as Q naught, but I will write it as Q infinity because this is the charge at infinity. Yes or no?
Yes, sir.
Then you have one time constant. The charge on one time constant increases from 0 to 63%. Yes or no?
Yeah, yes, sir.
Then you differentiate this, you will get current divided by C. You will get the potential drop across the capacitor. Yes or no?
Yes, sir.
These are how simple questions are framed I hope you understand this, and then you can solve this one. The question only asks you to find out the time constant for this circuit, but I would like that you tell me what is the charge on each capacitor as a function of time. Can you do that?
Yes, sir.
I'll give you 2 minutes to do it. Yes, that's
sir.
great. How do you get the answer for this one?
Sir,
It's pretty
capacitance,
simple.
resistance. Yes, sir.
You just find out what? You find out the equivalent capacitance and you find out the equivalent resistance, and then you multiply the two
Time
quantities. Yes
constant
or
equal to
no?
RC. Yes, sir.
Yes or no?
Yes,
But
sir.
if I would have asked what is the charge on each capacitor as a function of time, could you have given me the answer for that?
For
What
each
is the
capacitor,
charge
sir.
on each capacitor as a function of time? Remember, what we have done is we have replaced the two capacitor by a single capacitor, and these two capacitor were in series. Therefore, the charge on both the capacitor will remain same. Yes or no?
Yes, sir.
So, whether it's C1 or whether it's C2, what is the charge on C1 or C2 as a function of time? So, can you give me the answer for that? What will be the charge on the capacitors as a function of time? Both the charges are same. Can you tell me? Can you tell me what is the value? Charge on the capacitor as a function of time, because that is what that would be asked. Charge on the capacitor as a function of time, and that is what I am asking here. Charge on the capacitor as a function of time. I'll give you 2 minutes to do this. Don't worry, I'll do this. So how are we supposed to do this? It's simple. What is the final charge? Final charge on this capacitor, which is the series combination of two capacitors. At infinity, no current will flow. So the potential difference between the 2 points will be equal to V naught. Yes or no? So
Yes,
final charge on each capacitor will be C into V naught, where C will be equal to C1, C2 upon C1 plus C2. Yes or no?
Yes, sir.
Into 1 minus e to
E
the
to the
power
power of
minus t
T
by
by
r
2.
into C, where R is the equivalent resistance
Yes,
and
sir.
C is the equivalent capacitance. What was wrong here?
Yes, sir. I got, sir, but I have brought
Okay.
myself.
Okay, not a problem, not a problem. We might get confused, and that is why we are in the class, so that these confusions get over. Yes or no?
Yes, sir.
Let's see if you can do better in this one without using the formula for equivalent. You don't know what is that, so leave it. Find out the charge on the capacitor and the current in all the branches. How many branches you see? One is the main branch and the other two are the branches that are going inside. They have made both the capacitors same, but I can make this question a little bit different, and that is what I'm going to do. I will call this capacitor as C1 and I'll call this capacitor as C2. I will call this current as I1. I will call this current as I2, and I will call this current as I. You have to find out the value of I1 and I2 and charge on the capacitor as a function of time. Both the capacitor as a function of time. Can you do that for me?
Yes, I will try.
Time is on your side. I'll give you 2 minutes. Try it. Okay. Let's go about solving it. And it's pretty simple. Trust me. You first of all, what we'll do again, remember JEE 70% about how quickly you can do this. So first of all, I'll tell you the quickest way. We'll find the equivalent capacitance C1 and C2. We can do that, yes or no? They are in
Yes, sir.
parallel. It is
Yes, I
C1 plus
did.
C2.
Yes, sir.
So my C equivalent becomes C1 plus C2.
C1 plus C2.
And there's only one resistor here. So
Yes,
R
sir.
equivalent is R. So
Time.
I can replace these two by 1 and I can find the total charge Q which has flown. So this total charge Q which has flown through the circuit, remember this is the summation of the charges on each capacitor, and charge on each capacitor will not be Q naught by 2 because I've changed the capacitance. Do you understand this?
Sir.
So the total charge is Q The charge on this capacitor is Q1 and the charge on this capacitor is Q2. Do you understand this?
Yes, sir.
Charge on each capacitor will not be half because I have changed the capacitance as C1 and C2. So let us first find the value of Q. We can find the infinite charge on this combination and it will be equal to C equivalent multiplied, or C equivalent is C1 plus C2, yes or no? Multiplied by V0. V0 is E. Are you following me, bacha? That
Yes,
is the
sir.
infinite charge, yes or no?
Yes, sir.
Into 1 minus E
E to the power of minus t
minus
by
T by
RC
R into
or C1 plus
C1
C2.
plus C2. That is the total charge which has flown through the circuit. If I differentiate this charge with respect to time, what would I get, bacha? I will get this current I. Do we see this? The total current I. You got this?
Sir, I used
I
both
was
the
the current in the
capacitance
main
half.
branch. I was the current in the main branch. Do we understand this?
Yes, sir.
Okay. Now, how do I get the value of Q1? Remember, two capacitors are in parallel. How does the charge get distributed between the two capacitors? It gets distributed in direct ratio of capacitances. Do we know this?
Sir, I got doubt, sir. Here the charges are distributing as a current.
Charge will be
So,
distributed. Charge will be distributed in direct ratio of their capacitances. So Q1 will be equal to C1 upon C1 plus C2 multiplied by Q. Do we understand this? If I have two capacitors here like this capacitor is C1, this capacitor is C2, and Q charge is flowing. This charge flowing on this capacitor is Q1, charge flowing through this capacitor is Q2. You must know that charge will always divide in direct ratio of capacitances. Do you know this?
yes, sir.
So the value of Q1 will be equal to how much? It will be equal to this much.
So,
Yes or no?
yes, yes, sir. Yes, sir. Got it.
You know the value of Q. You can find out the value of Q1. Yes or no?
Q1. Yes, sir.
So it will be C1 into E into 1 minus E to the power minus T by whatever. Yes or no?
Yeah, yes, sir.
Similarly, your Q2 will be
Q2
equal
equal to
to
C2 by C1
C2
plus
upon
C2
C1 plus
of
C2 times of Q.
Q.
Yes or no?
Yes, sir.
Now, if I differentiate this, I will get the value of I1.
I1.
I1 is the
And
current
here
in
will
this
get
branch.
I2.
If I differentiate this, I will get the value of I2. Do we understand
I2.
this?
Yes, sir.
Confident?
Yes, sir.
You will be able to do a question if it comes on this nature. Yes or no?
Yes, sir.
Okay. I have more questions. I will try to cover as many as possible so that whatever we do, it gets logged and you don't have to do anything else. Shall I move forward in life?
Yeah, yeah. Okay, sir.
Done this, right? Where is my cursor? Okay, it is here. Okay. Then I would take you to this question. And remember, these are the type of questions you might find in the JEE. I'll try to cover each and everything, but let us now concentrate on one capacitor rather than moving on to different capacitors. A capacitor of 2.5 microfarad is charged through a series resistor of 4 mega ohms. In what time the potential drop across the capacitor becomes 3 times that of the resistor? ln of 2 is given as 0.7 or 0.693. You have 2 minutes to do it. Well done. The answer is indeed 13.8. Well done. How did you do it? I'm very
Yes,
happy to do
I
this.
take T is equal to RC and then I find out E value. Then the question given VC is equal to 3VR.
Okay, so you did it by the
Then
right way.
VR plus
Basically,
VC is equal to 10.
okay, you know V as a function of time, yes or no?
Yes, sir.
And you also know VC is 3 times VR.
Yes, sir.
So, and V naught is VC plus VR, yes or no?
Yes, sir.
So, you know VC is 3
VC is
by
equal to
4
3
V
by
naught.
4.
Once you get this, then it is pretty damn simple. Yes or no?
Yes, sir.
Well done. You passed this test. Then I will put you to the next one. Remember, this is how questions are framed in a JEE. A
This sort of
simple
questions,
question.
sir, sir.
Yes, beta?
This model questions will be framed, sir.
These all questions?
This types of questions only framed in IIT, sir.
Yes, yes. Don't worry. I will cover all types of questions that can come, and I can assure you one thing, that whatever topics I have covered, there cannot be a question that goes beyond it. I have that much faith in my teaching. Once I say that this topic is over, right? Thermodynamics still not over because we have not covered questions on heat transfer. We have not done many questions on KTG as well. Only the thermodynamic process part is done. So if a question comes on that part, you should be able to do it. We have not done questions on gas laws as well. Here we are still lagging behind. I cannot still say whether all types of questions are covered, but I'll try to cover them. This one, a switch in the circuit shifts from 1 to 2. 1 to 2. When VC was greater than 2V naught by 3 and goes back from 1 to 2. I think there's some, I'm not able to. In first case, it would be 1 to 2, then 2 to 1. Something wrong in that timing, I guess. I think it should be from 1 to 2. Okay, I think it should be the other one, should be the reverse one. The switch in the circuit shifts from 1 to 2 when VC becomes greater than 2V by 3 and goes back to 2 from goes back to 1 from 2 when VC is less than V3. Okay, I did not read it correctly. The voltmeter reads voltage as plotted. What is the period T of the wave form in terms of R and C? A very simple question, but put in a very complicated way. Have you understood the question? Even I could not. Even I read it wrongly. I thought that they have repeated the same thing, but in first case it is shifted from 1 to 2. Then it is shifted from 2 to 1. Do we understand this?
Sir, question समझ में नहीं आया sir.
So initially the switch is at point 1. With the switch is at point 1, what is happening? Capacitor is getting charged. Yes or no?
Yes, sir.
When the voltage across the capacitor becomes greater than 2V by 3, the switch is switched from 1 to 2 so that the capacitor starts to discharge. When the capacitor starts to discharge, the voltage will reduce. When the voltage becomes less than V by 3, it is again switched back from 2 to 1 to charging again. Then they have plotted the voltage across the capacitor. And you have to find the time period of the wave. This T you have to calculate. Got the question now?
Yes, sir.
Right. Well, I must tell you, the answer probably is not C. How to do this? I think it's pretty straightforward if you understand what is happening and which waveform is drawn. Let me take you there. What is happening in the time T2? Can you tell me that? What is happening in the time T2? In the time T2, the switch has been shifted from 1 to 2 and therefore the capacitor is getting discharged. Yes or no? The switch
sir.
has been shifted from 1 to 2. The capacitor is getting discharged and discharging equation is looks like this. Yes or no?
Yes, sir.
The equation of V looks like this. Yes or no?
Yes, sir.
Yes or no? The initial value of the charge is 2V by 3 because that is the time it has been switched. Yes or no?
Yes, sir.
Final value of charge is V by 3 because then it is switched back again. Yes or no?
Yes, sir.
From there, you can get the value of time t2. Yes or no?
Yes, sir.
Then when the switch is put back to point 1, it starts to get charged again. Yes or no?
Yes, sir.
This is the value of potential. Yes or no? The final charge will be 2V by 3 and the initial charge is V by 3. Yes or no?
Yes, sir.
From there, you can get the value of T1. And once you add T1
Both.
and T2, you will get your final answer. Yes or no? No or yes? You get it,
Yes,
bacha?
sir. Yes, sir.
What did you do wrong? Do you understand this? Where were you mistaken? Do you understand this? Where were you mistaken?
Yes, sir. Clear.
Where?
मैंने दोनों इक्वेशन को ऐड नहीं किया सर.
What have you done?
मैं प्रोसेस दूसरा किया सर. ये
Okay.
प्रोसेस नहीं किया सर.
Okay. Well, now let me take you back to the initial question that we started. Do you remember this question that we started with?
Yes, sir.
We had done almost everything in this question. We had found out the value of I naught, I1 and I2 at 0 time, at infinity time. We'd also find out the value of Q infinity. Yes or no?
Yes, sir.
Yeah, we also know the value of Q naught at 0 seconds. Q naught is 0. Yes or no?
Yes, sir.
One question. No, not one question. A series of questions are still left. Can you find what? Can you find the charge on the capacitor as a function of time? Three questions actually. In fact, four questions actually.
In
Find
the same question, sir.
Q, I, I1 and I2 as a function of time. And the question which is more likely to come in a JEE, because these three questions, which three questions? These three questions probably are beyond JEE advanced. But this question is definitely in JEE advanced, Karan. Find the charge on the capacitor as a function of time. The other three in green may not be, may be a bit more tough than what comes in an IIT. But Q as a function of time can definitely come. How will you do it? I'll give you 2 minutes to think about it.
That means, sir, CE by 2.
Yes, C by 2 is correct. So you just say and I will write it. What your answer is? Q will be equal to CE by 2. This is correct. Into 1 minus
1
e to the
minus e to
power.
the power of minus 2t by, sorry, minus 3 RC by 2.
This is what you wanted to say?
Yes, sir.
Well done. How did you get it?
सर फॉर्मूला अप्लाई किया सर मैंने और टाइम कांस्टेंट का वैल्यू में डाल लिया सर.
Okay. So
We have
you just
proved
put
that
the
before
value of
only,
Q
sir.
infinity. This is Q infinity. Well done. How did you get the value of time constant? Tau. You are getting it as 3RC by 2. How did you get it?
Yes, sir. R plus R by 2. When we, it will get a short circuit now, sir. This capacitor will get a short circuit after 3 resistance will there, sir.
No, it's not exactly that. Basically, what you got to know is something that we did in the previous class. Did I tell you something known as R Thevenin? Yes or no?
Yes, sir.
Did I tell you about Thevenin's equivalent resistance? Yes or no?
Yes, sir.
You have to calculate to get the time constant. You have to multiply Thevenin's equivalent resistance with the capacitance C. So basically what you got to do is between these 2 points, you have to calculate the Thevenin's equivalent resistance between A and B. Do we understand this?
Yes, sir.
How do I get the Thevenin equivalent resistance? First of all, you have to take this battery out and assume it to be short circuit. Getting
Yes,
my
sir.
point?
Same. Yes, sir. Same I did.
Then you find the equivalent resistance between point A
Point
and
A and point
point
B.
B. So this R and R will come in series. No, this will R and R will come in parallel.
Parallel. Then it.
Yes or
Then
no?
one more R will be in series. Sir. Then R plus 2, R by 2.
R plus
We
R
will
by
get a
2 will be in
3R by
series.
2.
And that is how you will get the value of this tau. Yes or no?
Yes, sir. Same I did, sir.
Okay, great. Now, once you get the value of this Q, getting the value of this I1 will be very simple because this I1 is simply
Current
dq by dt.
dQ
Yes or
by
no?
dt. Oh, yes, sir.
Yes or no?
Yes, sir.
What I'm giving you as a homework is how do you get the value of I and I2? Can you do it for me?
What, sir?
What I'm giving you as homework is finding out the value of I and I2 as a function of time. Can you do it?
Yes, sir. Now I will do, sir.
Okay. You want to do it now? Or you can do it because the class time is running over. So you do it at your home. Okay. And probably I will give you one more question.
Sir,
And
I का value, sir. Sir. I का value, wait, sir.
how will you get how will you get I or I2?
Wait, sir. I will tell, sir. Just wait, sir.
How?
Sir, I equal to dq by dt, na, sir.
No, I is not dq by dt. I1 is dq by dt, beta.
I1.
Q is the charge on the capacitor in this branch. Q is the current flowing in this branch. So I1 is dq by dt. Getting my point?
Yes, sir.
I1 is dq by dt, not I or I2. So what I'll do is I'll give you this as homework to think about at home. Can you do that?
Oh, yes, sir.
Okay. Think about, and meanwhile I'll give you one more question that you can do. Some parts you can do here, one part you can do here, and the rest you can take it as homework. Similar part that you can do here, and similar part that I will give for you as a homework. Getting my point?
Yes, sir.
So that you understand how questions are framed in a JEE. And this is how the question looks like. Let me just try to get it on the screen. And as you can see, this question is pretty simple to what I gave. My question was all the resistances were same here, all the resistances are different. You can still do it. In the circuit shown in the figure, the battery is an ideal one with EMF V. The capacitor is initially uncharged. The switch is
Same.
closed at time t is equal to 0. The charge of the capacitor is a function of time. You can calculate this. Please draw the circuit. You can calculate this.
Yes, sir. Same question we have did before that.
Same question. You can calculate this, right?
Yes, sir.
So that is question number 1. Just write the values of the resistance R by 2, R by 2, R and 5R by 2. This is how the question is there. And then there is 2 more questions here. There is 2 more questions here. Similar to what I have given. The current in the branch AB. AB is the vertical branch. Same branch which I had given. Current in the branch AB as a function of time. And you have to find the value of this current at infinity. Again, if you find it at infinity using our actual tarika, or you put the value of t as infinity here, or you put the value of t as 0 here, you will always get the answer
Yes, sir.
which you are getting in the first question. Are you getting my point, beta?
Yes, sir. At t equal to infinity, it will behaves like
If t is equal to
open.
infinity, you have to get the answer at infinity. If you put t as 0, you should get the answer at 0. We have calculated both the values in the first question. Yes or no?
Yes, sir.
So that is how you can check your answers, whether your answers are correct or not. So I've given you these two questions. Try them at home, and probably in the next class we'll do more questions. Do you want more questions on RC circuits?
Yes, sir.
Okay.
सर इसमें से surely एक question आएगा ना सर RC circuit में से?
See, I can't say whether surely a question will come, but I can say if the question comes, you will be able to do it.
Yes, sir.
Normally it comes. Normally it comes. Either it's from capacitance or resistance or RC circuit. There must be a question. One or two questions maybe. Now,
Oh,
I can't assure you whether the question will come, but if I can assure you if a question comes, and I will try to cover your capacitor as well in the next class, giving you some questions on capacitors as well. So I can assure you whatever we have done in whatever time we have got, I can assure you that if a question comes from that particular topic, we would have covered it. Okay, you're getting my point?
yes,
So
sir.
in the next class, we'll try to wind up RC circuits, as well as we will try to, I will give you some question on capacitances as well, which I think might come. Okay, not on dielectrics, because if I go into dielectrics, then I will have to do more questions. So taking apart dielectric from the equation, I'll give you question on circuits and capacitance, and I hope I will restrict myself to questions which are of capacitors and circuits. Okay, because we have limited time. Do you get this?
Yes, sir.
Okay, so I'll restrict myself to capacitance and circuits, capacitance and resistance, capacitance, circuits, and resistances. So all these three we'll try to wind up in tomorrow's class. Today's class is over. If you have any doubts, you can easily ask. Else, good night.